So the calculator can find definite integrals for us. Okay, this is not going to be, we're not going to use this feature until next week when we get to the calculator portion, but I want to start introducing this to you. So if you can go to the second page. If you guys can make a slight adjustment to the problem. Yeah, the calculator. Right. And I had the square root extend a little too far. So it should be square root of 7 with the x outside. Okay. What we're going to do is we're going to practice entering this in the calculator, and I'll show you the keystrokes for that. So when we evaluate definite integrals, oh yeah. Okay, is anybody missing this from yesterday? This handout here. It's this calculator, TI 83, 84 graphing calculator. Yeah. Okay, new one. Also, yesterday I ran out of copies of the PVA worksheet. I know some of you guys didn't get one, so you can raise your hand if you did not get that PVA worksheet from me yesterday. Okay, so first thing you do is you on the graphing calculator, go to Math 9. So Math 9 is that first column, Math. Turn it on first. So Math 9, you're going to see that integral notation. Math print is nice because you're going to just plug in exactly what you see there. So lower bound, upper bound, integrand, and dx. On the 36 Pro, you see there's that integral notation in blue, and it's under E. So if you do second E, I'll pull up that integral notation, and it's going to enter in what you see. Oh, do Math 9. Math 9. And it's also spelled out right here. So Math 9 F an integral there. Yeah, sure. So the original problem, if you can just have that square root of 7 and not have the square root involve the x. Let x be outside of that square root. Okay, we're just practicing entering it in and understanding how to involve the calculator for definite integrals.
How do you get x?
Okay, so the way you get x button is on that second row. See that link, but yeah, x. And make sure you don't forget about the dx. On 36 Pro, the x is located next to the 4. Again, make sure that the x is outside the square root. If x is inside the square root, it's going to cause an issue because there's a negative here. So I made that mistake on the handout. I didn't change it.
Can you restart real quick?
Yeah, I'll come around. I'll help you.
Is there a way to like keep it right here? But like for this like test here.
That's cool.
Yes.
You know, practice
And then just
just
have to- And then just make sure that the x is outside the square root.
Oh, I like multiple.
Oh,
Sorry.
okay, I get that.
Yes. It's very.
Okay, so, raise the third power.
What kind of calculator you got? Lord. man.
Okay, it's just, this is careful.
Oh, God.
Yeah, I'll let you borrow one.
I got this geometry. Mr. Williams never did me wrong. Mr. Williams, oh God.
But I'm used to it.
Unfortunate. I've only had this one. I meant like a biograph. Oh, I'm forgetting.
I have the 8, and then I was like, gosh, I should just have Yeah. Makes sense.
Okay, everybody good with keystrokes? Everybody good finding definite integral notation and plugging in x? Okay. The next thing I want to show you is make sure that we can that we know how to enter absolute value notation into the calculator. So if you look a little below here, evaluating total distance, we're going to need that knowledge for next week as well. So we're going to go to Math 9, just like before, but there's an ABS button which is found under Math Number ABS. Okay, and I'll show you the keystrokes there. So do Math 9 to get your integral notation to show up. Here we're going from 0 to 5. And then go to Math, which is under that first row of buttons there, first column of buttons there. And then scroll over to Num on the header. And then option 1 is ABS. That's absolute value. And then you can enter in your expression value, 3x squared. Make sure you don't forget about the dx at the end. On the 36 Pro, get the integral notation to show up, 0 to 5. And then you're going to go to Math, Number, ABS. Okay, anybody have any,
Wait, how do we do it?
so you're going to go to Math 9.
So I got that.
Good. Okay, so you start from this and then keep going. So from 0 to 5.
You want the rules?
You're going to the space here.
Oh,
That was Give me that.
Oh, yeah, I was so confused. Yeah.
Where you didn't even put the integral in.
I was hoping it was just like.
So
I wasn't like, no way.
Okay, any issues here?
Where are you?
Some of them clear.
How are you?
Oh, I have to be, yeah, that's yeah.
Okay, any issues with definite integrals or with absolute value? Okay, the last thing I want to show you is make sure that we also know how to evaluate the derivative at a point. So if you go to the first page here, the calculator can't find the derivative function for you, but it can evaluate the derivative at a point. It can plug in the value into the derivative. So let's say I want to find f prime of 7. I can make the calculator find that value for us. So again, let's enter in the function but let's do math 8. So math 8 will be the derivative feature. Math 9 is the integral feature. Math 8 is the derivative feature. So we do math 8. There's that d over d notation showing up. So we're going to put x in the expression, and then you're going to say x equals whatever that value is. So let me do it on the graphing calculator first, and then I'll show on the 36 Pro. Okay, I'm going to enter this function here. Again, I'm going to make the adjustment. I'm going to pull that x outside the square root. And if you want to get that exponent to show up, you can always hit that. There's that button above the division sign that looks like an up arrow. So that indicates that you can go into the exponent region and plug in the exponent. And then you're going to make the calculator. The calculator is going to find the derivative at a point. So you're going to enter in whatever x value you want to evaluate the derivative at. Yeah, I use 7. And then if you're using 36 Pro, you see there's the integral notation for second e. There's the d over dx derivative notation for in blue for ln. So if we do second ln, you'll get a similar notation to show up. Okay. Any questions? Anybody have trouble finding those decisions? Okay, there's a bit of a shortcut involved with 84, especially if you're wanting to continue to pull the same function over and over again. But I'll show that next time. But at least the most important keystrokes I've gone over with you. Okay. The next topic I want to make sure to go over is being able to find the depth integral for absolute value without a calculator. Okay. So I want to make sure I go over those methods with you. So if you guys can go back to your packet, well, you can put it anywhere because I did not put this in any of the notes. So if you can just find any empty space that you have. And I just want to go over notes for depth integrals involving absolute value functions by hand. On the old packets, there's a blank page on the last page. If you want to put it there, that's fine, or in your notebook or any blank page that you have. Okay, so go ahead and write this down here. Depth integrals for absolute value functions. Yeah, put it anywhere. Yeah.
Like the most recent package?
It's the yeah, the use substitution packet. There's a blank page at the back. If you want to put it there, you can. So let me just kind of go over absolute value functions. Absolute value functions kind of has a V shape, right? And because of the fact that the absolute value function kind of gives that diagonal lines, we can actually just involve geometric shapes to find the area for depth integrals without having to resort to calculus if we didn't want to. So just as a review, though, absolute value of x, okay, has the shape, right? And the numbers that follow after it, either inside or outside the absolute value, indicates where the vertex is. The vertex is going to be kind of like the center of the absolute value function. So in this case, absolute value has no numbers inside or outside, so it's really 0 and 0. But usually what we do is we take the opposite of that value, the opposite sign, and then we keep the sign of the outside, and that is the vertex of the absolute value function. So for instance, if I have y is equal to absolute value of x plus 2 minus 5, the vertex is going to be involving these two numbers, but I always take the opposite sign of what's inside, so the vertex will be -2, comma, -5, just as an example. Okay, but we're going to start off just with absolute value of x. Okay, and we're going to go from -2 to 4. So I want to show you how we can do this by hand. Okay, so here's example 1. Now we could use power rule, but it's a little messy because with absolute value, we have to split it up into piecewise functions and then do power rule. I think the easier way is to just sketch the graph out and then just add areas of triangles. So I want to show you how to do that. So first is, let's figure out what this graph looks like. Okay. Absolute value of x is just going to be a graph, absolute value function centered at 0, 0. And then from there, you know there's a positive sign in front of absolute value, so just sketch the graph.
Does like the y and then for b, does that go from the 1 to? Or is that just, you know, this is y like absolute value?
Let's see. Yeah, so this is y equals absolute value of x. So we're sketching y equals absolute value of x.
Oh no, I was talking about like the thing you just erased. Was that also for number 1 or is that?
Oh, that was just an example to show how we can pull the vertex.
Oh.
Yeah. So once you have the absolute value function showing, now the next step is understanding the intervals, right? We're going from -2 to 4, so it doesn't have to be accurate. You know that the graph is going to be V-shaped, but now we're just looking at the graph between the absolute value function and the x-axis. So if you see here, we're talking about this region here. So the nice thing about absolute value function is that it's always going to produce a nice geometric shape. We don't have to rely on calculus. So we can simply just find the areas of those two triangles and then just add them together. All right, so the area of a triangle is 1/2 base times height. Okay. So this first triangle here has a width as a base of 2. The way you find the height is you just have to find where the endpoint is going to touch the graph. Okay, so all we do is we take that endpoint, plug it into the function, and figure out what the y value is. So if I plug -2 in for absolute value of x, what's that going to give us? 2. So I know my order pair is -2, 2, and that y value is also going to represent the height of my triangle. Okay, moving on to the triangle on the right, my base is 4. And to find the height, I'm going to plug 4 into the absolute value function. Absolute value of 4 is just 4. So my height is 4. So yeah, so I have 1/2 base times height for my first triangle, and then 1/2 base times height for my second triangle. This will give me 2. This will give me 8. And 2 plus 8 equals 10. Yeah, there's another way to do this using piecewise functions, but I think this is the quicker, faster, more efficient way to handle these types of problems. Okay, you'll see one of these problems on the test for Friday, so I want to make sure I go over it with you. Okay, let's try one more. Okay, any questions so far? All right, so I have the work here in case you want to copy. I'm going to erase this here. Okay, so let's try number 2 here. integral from -5 to 5, absolute value of x plus 4 dx. Okay. Sketch the graph, find your endpoints, draw your two triangles, and do 1/2 base times height for each triangle. Okay. First step, where is the vertex of this absolute value function? Yeah, so it's always the opposite sign of what's inside the absolute value, and then whatever number is outside. In this case, there's no number outside, so it's going to be 0. Yeah. The absolute value function is either going to be right side opening right side up or opening upside down. But the way you can tell is you look at the sign in front. If there's no sign that's positive, and it's positive, the graph is going to point up. But if there's a negative, then that means your graph's going to open down. In this case, it's going to open up, so you just have to sketch the graph out. Okay, we're going to go from -5 to 5, so we're going to mark those intervals off. So the formula for finding the vertex is always the opposite of what's inside the bracket, right? So we see that with the vertex form as well for quadratics. So it's always the rule there. Okay, so you guys see the two triangles begin to form here. Again, it doesn't have, your graph doesn't have to be accurate. It's just enough for you to have to be able to pull what you need to pull for 1/2 base times height, right? So the accuracy of the graph is not that important. It's just, are you able to use the graph to kind of help you pull information that you need? Okay, 1/2 base times height. I know that my base is 1 here. My base here, if I count, that's going to be 9. Okay, to find the height, I'm going to enter my endpoint into the function. If I plug -5 in for x, what do I get? Yeah, -5 plus 4 is -1. Absolute value of -1 is 1. So I know the height of my first triangle is 1. Okay. Take the other endpoint, insert into the function. 5 plus 4 is 9. It's already positive, so. And now we just add up the areas of the two triangles.
So your height's 9 to 5?
Yes, because if I plug 5 in for x, 5 plus 4 is 9, absolute value of 9, so that's my y value, which also happens to be the height of my large triangle. Okay, so 1/2 base times height, and then the triangle on the right, 1/2 base times height. One half plus 81/2 gives us 82/2, which is 41. So Friday is non-calculator test, and this is one of the types of problems that we need to be able to demonstrate how to do on the test. So these types of problems have shown up on non-calculator sections of the AP exam. So this very specific method is not hard, but it's just kind of unique to its own. Okay, questions? Okay, so the new packet that you just picked up. I called this the 4.3, 4.5. Before in the past, I had a quiz over this section, but we're just going to use this as review for Friday's test. Now, now what I want to make sure that before we go through this problem here, if you guys on your calculator handout, turn to the very back page. So the back page is the formula sheet that you're responsible for knowing. Now, there won't be any summation or limit definition on the test, so don't have to worry about that. But you will have to memorize formulas that you did on the quiz, plus a couple of extra ones. So you know power rule, you know trig derivatives. Okay, definitely review those. And if you know trig derivatives, you also know trig integrals, right? Because you're just going the other direction. So I have those trig integrals highlighted there. So you have to know power rule for derivatives and power rule for integrals, right? For use substitution, you got to be able to go back and forth. First theorem is just evaluating definite integral, right? You do power rule and you plug in upper and lower bound, minus lower bound. We've been doing that a lot. Second theorem, we'll go over that tomorrow. But right now, we're going to practice average value theorem. Yes?
So like the summation, like
that's not on the test. Okay. So I highlighted the ones that you're going to have to know and memorize for the test. The variations of first theorem, we'll get to that when we get to next week. But this you don't have to worry about as much. Okay, so let's go to number 1 on the 4345 review. Yes.
Are we gonna have like the long limit problem?
No, this limit definition, we're done with it. I won't test you on this on the test. Yeah.
At the end of class, could you like go to the quiz and say which ones, like which type of problems?
Yeah. So here is a good indication. The next page, page 3 and 4, is the test review. So if you look through that, that's exactly what to expect on the test. Yeah, so tomorrow we'll focus our attention here, but basically it's going to be laid out the same way. Okay, so page 3 and 4, what you see there is what you can expect on the test for Friday. Okay, so let's go to number 1. Okay, so start off by going through average value theorem. Okay, so average value theorem. Here's the formula. We have to make sure we work towards memorizing this. It's really just height is equal to area divided by the width. Okay, so first things first, you have the function, you have your a, you have your b value. You're just going to go ahead and insert them into your formula. Okay, so try that first. Okay, so we start off by just going ahead and replacing all the a and b with 0 and 3, replacing the integrand with the function. Okay, so what do we do first after we get this set up? Good, power rule. Okay. What I want to make sure, I see a lot of students do this, and I want to make sure that we don't do this, is that the 0 and 3 does not play a role into this expression. Okay, the 0 and 3 does not get plugged into this expression. The bounds is the last thing that we do. Okay, we got to do power rule first, and then the bounds plays a role for our answer. Okay, so you got to spend the time to do power rule first, even though the bounds come first. That's not the first thing that we do. Okay. All right, so go through power rule. X squared becomes
2x minus 2.
X cubed over 3.
Yeah, so we got so power antiderivatives. Yeah, so we got to add 1, right? Add 1 to the exponent divided by that exponent. Okay, so x cubed over 3, 2x becomes
X squared.
okay. Yeah, 2x squared over 2. The 2's cancel out, and the 3 becomes what? Good, 3x. Okay, doesn't go away. That's derivatives. Integrals are going to increase the degree by 1.
There's no plus C here, right?
Right, no plus c. You only do plus c if there are no bounds. If there are bounds, the c just washes out, so we leave that alone. Okay, so this is what we should be looking at right now. Yes.
Could you make the x cubed over 3 1/3 x cubed?
Yes, you can.
Can
Yeah.
you simplify before you do your?
Right, so first I want to make sure, is everyone okay with this? You can reduce and cancel out and do a little bit of cleanup if you like, but for the most part, you guys good with this step? Okay, so here you have two options. Either you evaluate the bounds, leaving the 1/3 out of it, and then wait for the end to involve the 1/3, or if you want to just multiply the 1/3 through first and then evaluate the bounds, you can do it that way. So there's two options you can do. The important thing is that you have to involve the 1/3 either now or later. Okay. My preference is I'm going to wait till later to do it, but if you feel like you, but I also understand if you want to involve the 1/3 at the beginning so you don't forget about it. So it's up to you. Just have to, whatever method you want to do. I'm just going to go ahead and evaluate the bounds and then deal with the 1/3 at the end. Okay. If you do it the other way, we should still arrive at the same answer. Okay. Upper bound gets inserted first. And then minus, big parentheses. And now you can involve the 0, okay, or the lower bound. Insert the lower bound in for all the variables. So I get 27 over. I know this is, the nice thing about this is that this all goes away. 27 over 3 is 9, minus 9 plus 9, which is 9. But I don't want to forget about the 1/3 in front. Okay, so f of c. So I have the area component, but I don't want to forget about the width component. Right, so area divided by the width is equal to the height. That's part A. So part A, f of c is equal to 3. Part B says find the value of c guaranteed by the theorem. So basically this is saying that I know what the average height is, which is 3 on the graph, but I want to know where is the graph going to hit that y value of 3. So how can I find the c value? Good. Well, yeah, involve the original function, but we got to make sure we plug in the right spot, right? Where does that 3 go? Good. It goes in for the y location, right? Not the x, right? That's the y value. So now we just have to work and solve for x. Three goes away. X equals 0 and x equals 2. Now, in this case, it's okay for the c value to land at the endpoint. Okay. I know we couldn't do that with mean value theorem with derivatives, but with integrals, average value theorem is basically mean value theorem for integrals. If it lands at the endpoint, we can still keep it. So we have two locations where the graph is going to touch the average height at 0, at x equals 0 and x equals 2. Okay, any questions? Few minutes here. I just want to kind of give you a preview as to what we're working towards. So page 3 and 4, again, shows you the types of problems that you'll be responsible for the test. So number 1 is like power rule, expand everything out. Number 2 is like a use substitution problem, expansion, use substitution, change a variable with use substitution. We'll practice with that. Page 4. Second theorem, we'll practice second theorem with 7 and 8. Just did absolute value, we can practice with that again. Average value theorem, and then taking the antiderivatives using power rule. Okay, so those are what we're working towards for Friday. Guys, a couple of help sessions coming up tomorrow through Friday. I'll send out this in a reminder this afternoon.
Okay. So do we need a graphic calculator for next week, or can we use one of those?
You can use one of these, but are you able to? Do you think you're able to get one of your own?
Oh yeah, no, I can definitely get one of my own. Yeah.
Yeah, I mean, graphic calculator is going to be better in the long run, but you could get away with this. It's
Gotcha.
just some things you can't do as well without the.
Okay, got it.
Okay.
Thank you.
I hate them.
So after this, you only have 2 more units before they change like the size.
Yeah, after this unit, we'll have chapters 5, 6, that's merging the 1, and chapter 7 is going. Yeah, so 2 more units. We should be done with that second unit by 3rd week of March.
So when we do the games, are we gonna have quizzes and tests?
Yeah.
Are summations part of it?
Yeah.
Not directly.
I just want to make sure I did it right.
Fine.
So I
Not really,
Okay.
not really. But the limit definition, sometimes they throw
I
that
looked
in.
at you for a
So
basketball.
you should understand how.
You're just looking so 2000, which I love.
I had a question. So for like the test pattern,
Bye every day.
is it from like 4.1 to like 4.3, or is it kind of just like all over? Is it like a certain set of like?
Yeah, it's 4.1, 4.2. Yeah, it's basically all of this, but it's just, but I just, for 4.2, I take out, there's no summation, and there's no limit definition. That's all I'm removing, but everything else.
Okay, kind of sure. Just so I know.
Okay.
Study. Thank you.
Uh-huh.
Have a good day.
Have a good day. Oh, did you have any questions about the quiz? I saw some mistakes there. You understand what you?
I think, yeah, I think I was just making like stupid mistakes.
Yeah, because I wanted to make sure that you feel comfortable with those problems before we get into the review.
This one I just put in 4 thirds instead of
Okay.
like
So you understand that?
Yeah.
And that's, so you're gonna find, so you found the width very well here. You find the width the same way here. So it's 2 to 15. So that's, yeah, you got 2 to 15. 5 minus 2, that's the width. You don't want to do that.
Yeah, I don't know why I thought I was like, I felt like we had used that for like something, and I was like, maybe it was. For
You did do that for, okay, I think
I switched them?
Got it. You switched
Okay.
them, yeah, so the width is 5 minus 2, and the 6 plus 9 is 5.
Okay, and then, yeah, this one I just got like completely confused on, but we went over, and that, I just, yeah. Okay,
All right.
thank you, Mr. Have a good day.
All right, see you later.